Good morning, ladies and gentlemen. Good to see everybody here today. Missing a few of us. Try to get by. Okay, we finished problems 1 through 12 yesterday, so we're going to be starting on 13. And a lot of what 13, as you can see the instruction at the top, determine whether two variables vary inversely or directly, then write an equation and use it to answer the question. And so we're going to be comparing and contrasting the, let's see, I think it was the day before yesterday, I think we talked about what direct variation was and inverse variation, just kind of, so now we're going to see real examples of it. So what is direct variation? Yeah, so Chloe just said it's y equals x times something, or what it's the, and really the way I explained it the other day, it's like you have the thing y equals mx plus b, but where b is equal to what? 0. And so what you are is you're just kind of left with the y equals mx portion of the slope-intercept form of the equation. That's a direct variation. And what you're going to have, what you'll notice here, is when you have a direct variation, is you have y increases as x increases. So x gets, well, as x gets bigger, y is going to get bigger. As x gets smaller, y gets smaller. And we sort of have a binary choice today in our exercises. Each of these examples is going to be either direct variation or inverse variation. And so what I like to do for this is you kind of look at a table, and what you do is you can draw arrows in the order of increasing. So up here, x is increasing, but what happens down here? The y's are going the other direction. And so what does that tell you? Not direct variation. And by process of elimination, this is going to be what kind of variation? Inverse variation. And what we're going to have here is we're going to find out what that is. And so what I want to do is I want someone, I'm going to call in a volunteer to answer the question given the table of data, what is y when x equals 15, and that's going to be, and you can use some of the work you've done in prior problems to kind of give you an idea of how that might work. So I'm going to call on somebody for that. How's that?
Yep.
That would be a good thing you guys can do. So I'm just going to go ahead and call on one of our good people. I don't know who it is yet. Oh, Braden. Braden, okay, Braden, very good victim to start out the day, Braden, good job. All right.
I got
2. Okay, so Braden says y is equal to 2.
Yep.
So let's go ahead and look at this. So I'm looking at, when you multiply x and y together, what do you get in each case? 1 times 30, 30. 3 times 10 is 30. 4 times 7.5 is 30. So what times 15 equals 30? It's going to be y equals 2. So I think that's a correct answer, right?
All right.
All right, good job. Okay, what I'm going to do is I want you to go to 14 and work on that one. I'll call on somebody here in a minute. All right, this one here, is this going to be an example of direct variation or inverse variation?
Direct.
Correct, right, okay. All right, let's go ahead and we're going to pick somebody else for this one. It might be a picking, oh, Lexi is a wheel favorite. All right, Lexi. 150. So y equals 150, she says. Let's check this out. So what you have is y, I'll say y equals mx. I'll just put it like that, right? And so what we have is 30 is equal to m times 2, right? And so solving for m, what is m? 15, right? Oops. So m is equal to 15. And so therefore, if you take y equals 15 times 10, which equals 150, does that look good?
Nope.
Okay, that's good. Looks good. Thank you, Lexi.
Great.
Yeah. What I should have done, I made a mistake on that one. I should have got Lexi to explain it a little better. But I'll try to do a better job on the next one. So,
I did 90 times 2. Yeah, it's
here.
what did you get? Yes, 30. I think. Anybody else want to go up
Number of people times the cost per person equals 180.
Okay, so let's go ahead and get a new player here.
Whatever C is.
I love when people go bankrupt.
If they're one divided by 60.
It's going to be Chloe this time.
That's my favorite.
Best dressed.
The best dressed. We got the best dressed person here, who's walking around, not limping, but she says she can't play still. Okay, go ahead.
Game day.
Yeah, it's game day.
Okay, I got $30 per person for my answer.
So $30 per person.
What's wrong?
How do you get that? I'm so confused.
Yes.
So much.
So I'll put a question mark out here because we have a lot of people who apparently don't believe, but make us a believer, Chloe. Make us a believer.
Alright, so I got the number of people P times the cost per person C equals 180.
Oh.
So what you're doing is you're going back to the strategy in the first part of the set we worked on yesterday, right? Okay, good.
And then, well, we're looking for the cost per person, so you divide by the number of people, which ends up being 6.
So you get C equals 180 divided by P, which in this case is going to be 180 divided by 6. Oops, 180 divided by 6, which would be 30.
Right.
And then so C equals 30.
So C equals $30, okay? So we just kind of look at that. Yeah, it looks like the constant of, and this is, by the way, what kind of variation? Inverse variation, right?
Yes.
No, for direct variation, you just kind of figure out what X is being.
Okay, good.
Yeah.
Good, I like that. That's good. Good explanation of what was going on here.
Yeah.
Inverse is like, so the rest is if they're both increasing.
Oh.
Inverse is if the top one's increasing and one is
Can we explain that again?
Okay,
Inverse is just.
It's just inverse, so it's going back to the then so you have the IC equals 2 times 9 equals 6.
No.
And that's that inverse. Yes.
okay, here we have another situation. Let's see who's our next candidate today. It'll be Aaron, okay. Okay, we've been getting Aaron a lot lately. That's good.
Hey, Ron.
He's been good. All right, Aaron, what do you think?
Yeah.
Oh, wait, yeah, I'm the director.
I got 12.
Yeah.
So 12, what amount of gas? So 12 what?
Gallon.
12 gallons? Okay, how did you work this out? Estamos esperando una respuesta. How do you work it out, or was your logic, or anything?
Not really anything.
Say, $112, what about one?
You go ahead and do it.
Now one thing about it is when we do these problems, there are a lot of different ways to work them out. One way I just thought of doing it is you could work it out as proportionality, can't you? So you can have like 4 is to 112 as x is to 336, right?
Yeah.
Anybody work it out that way? Well, you see that's a logical way, right? And then if you take 4 times 336 divided by, and you can, I hope you can see that if you cross multiply the 112, that's going to cancel. See, if you cross multiply the 112, this is going to be 1/3, right? So 4 equals x over 3. Cross multiply, you got x is equal to 12. So that's one way to do it. There are probably a lot of different ways to do it. That's one thing, when you have a direct variation, you can always write it out as a proportion. Okay? I don't know if that's helpful, but okay. A lot of different ways to do these. Okay, I'm gonna pick somebody for 17.
Oh, no, that's what it's being, yeah.
I got 28 plus 3.5.
It's direct variation.
One thing I'm hearing today in class, and I appreciate from this class, is I'm hearing a lot of good conversation on topic conversation. That's very, very good. That'll be Bryce, all right. Bryce.
For my final answer, I got 49.
So what is 49?
That is the rental cost.
So cost
C.
equals 49, and $49 is what you meant, right?
Yeah, right.
Okay, good. Help us understand your.
Okay, so the way that I thought about it was, you see the 2?
Uh-huh.
The 2 going to the 2.5? That's plus 7, right?
No.
And then
Okay, so you're saying
at the bottom is.
so you're saying this. So you're saying this is plus
Yeah,
7,
plus
okay?
7, right? And then the 2.5 to the 3, the rental cost goes plus 7 again.
Okay,
Right.
plus 7, yeah.
So I just saw a pattern. So I did the 3.5 must be a plus 7. So the answer would come out to 49. That's just how I did it.
So 42 plus, so this one has to be by that kind of logical reasoning, it has to be 49.
Right.
Okay, man, I don't know, I like it.
Like it.
I like it, using the slope, because one thing he did is he checked that he had a constant rate of change, right? And because these things were constantly spaced, he was able to sufficiently determine that, right? No, I like that. This is a good strategy. And what kind of variation is this?
Direct.
Direct variation, okay? Good job. Now, are you sensing here, when you work on these things, that there's a little bit of room for creativity?
Mm-hmm.
Yeah, there is, isn't there?
Just kind of big.
Are we doing papers or if it's direct, but the numbers stick around? I would.
Dang it.
All right, number 18.
Mark. Jose. Or Marcus.
Just. Dang it.
Jose, all right.
That's Jose.
All right, Jose.
So for my final answer, I got 16 hours.
So how much time? So 16 hours?
Yeah.
So you say T, how much time you're looking for? So time equals 16 hours? Okay. What kind of variation is this?
Inverse.
So inverse variation. Okay, how did you figure this out?
So I started by getting the 42 and then 48 and multiplied it by 2.
So you have 2 times 48.
And then I divided 96, which is the
So that's their 96, okay.
divided by 6.
So 96 divided by 6 is equal
And
to
then it comes out to 16.
16, okay. So that's going to be, let me see, it's going to be 96 over your painters is equal to the time, right? That's what that looks like being. Now this one here, they tried to do a little bit of sleight of hand because they put the well, it's not really sleight of hand. I thought they switched the direction, but no, they didn't. All right, good job, Jose.
Good job, Jose.
So go ahead and work number 19. I'll choose somebody for 19 in another minute.
Okay, so I got that it was, I got it that was right first. And then somehow I got 72 over 6, which is my answer. It's because the rate of change is 6. And so 72 divided by 6 equals
Oh.
You know, so Chloe, you don't have a good calculator today?
it's somewhere.
Okay, well that's okay.
She don't need it.
It's okay. I dropped mine on the graph, but it's still right.
All right.
It's still right. Yeah. I dropped it.
Okay, now 19. I think I remember watching this in the video
Oh,
that I did.
Mark. You ready, Mark? Mark.
Because he sort of knows how much the wheel spins.
I divided 30 by 5.
So 30 divided by 5.
Yeah. And then I divided 60 by 10. Then 90 by 5, by 15, I mean. And all of them equal 6.
Shine your next.
So then,
Okay, now, I want to just interject for a minute here. Because what it was, is that he looked at it, and he was trying to be, he wanted to be 100% sure about this, at least as the best, as much as possible with the data available, okay? All right, go ahead.
and then, so I took 72 and divided by that, by 6, and then I got 12.
So this is what kind of variation?
A direct.
Direct variation. And 12 what?
This one didn't do it. I don't know. Oh,
What is the bicycle speed when the cyclist pedals in a race? So 12 what?
miles per minute?
How about this?
An hour?
Miles per hour. They give you the units right here. See that? Okay? Okay. All right. Somewhat good. Number 20. I'll choose somebody for number 20. And
no, I wanna go start. We'll see who wins.
I'm gonna get it.
You ain't gonna get it.
Alright, watch. What'd you get?
Me either.
You said you took it.
Yes,
Well, you know,
that's my answer.
all right.
oh, is that why you guessed 72? Yes.
Yeah,
That's funny.
All right.
Well, it's Scott.
This is it here.
Keep me,
I mean, it's me, I know it.
yeah, it's gonna win on CP. There's a 33% chance, but I know it's gonna win.
I told you.
He cheated.
I know what it is.
Maybe he did.
Maybe.
But sometimes we have to deal with cheated elections. All right. Let's go ahead. It's called getting on with our lives, right?
Yeah. Alright. Well, this is what I did. I multiplied. Oh yeah, I multiplied 600 times 60, and I found out that was 36,000. And then 720 times 50 is also 36,000.
So 600
Did you just call me girl?
times 60 is what?
Girl?
Girl? Yeah,
36.
36,000.
6,000. Okay.
And then 720 times 50 is also that.
So 720 times 50 equals same thing.
Yeah. And 800 times 45 is also that. So I just took 36,000 divided by 500.
So you took laptop 500, so you had like, it looks something like this. PL equals 36,000, is that right?
Yeah.
And you want to find laptops, so that's going to be
So it'd be L,
number, you want to find the number. So L equals 36,000 divided by P, right?
what I got.
Equals 36,000 in this case divided by 500, which is going to be
72.
72 the laptops, right? Okay, does that look right? Okay. What I want to do with the last 5 minutes of class or so,
Chill.
Is- I want to talk about
No. There you go.
Everybody else got.
Oh, Marcus got two.
I got a blue star.
Wait,
Which one are these in?
You want my stars?
All right.
Y'all pick it up, Mr. G?
Yeah, you pick it up. I want to just briefly start talking about something we're going to be doing on Monday.
I like your schools.
All right. This section here we've been working on I want to tell you something. This one right here. Did I talk about who figured out the relationship between string length and octaves and all that? Pythagoras.
It was an A.
Pythagoras, right? I talked about A's, that's right.
Really low.
So anyway, talked about that yesterday a little bit.
Just keep letting it happen.
Okay, thank you. Okay, what we're going to do is we're going into section 9.2, and we're going to work on graphing rational functions. Okay, simple rational functions. And basically what we're doing is we're changing from 9.1, which were rational functions, but like real world uses of rational functions. Now we're kind of regressing, if you want to call it that, into like the more academic equation of what a rational function is. And here we have, how are the graphs of a times 1 over x minus h plus k related, and this other graph here related to the graph of f of x equals 1 over x. So that's really what we're going to be dealing with. And this graph of f of x equals 1 over x, what have we called that? What's been the label we called that? Well, we call it the parent. Either the parent rational function, here they call it rational, but I've called it something else. Sometimes you hear it's called the reciprocal function. Reciprocal, that's another way of saying it. Inverse identity function, that's another way of saying it. Another way you could write this is you could write this as f of x equals x to the negative 1 power, right? And so is this going to be an odd function or an even function? It'll be an odd function. Has 180 degree rotational symmetry. So what we're going to do on Monday is talk a little bit more about effects of translating and behavior and other things. And then we're just going to go from there. And that will be what we're going to be working on Monday. All right? Questions on that? All right. Great. Thank you.